In this video, we shall know the properties of binomial coefficients and its relationship with the Pascal's triangle. It is very troublesome to calculate 20 choose 18 using this formula. But we have another formula that provides us convenience with it. It is n choose r equals to n choose n minus r. Let us give an illustration to it. Let's see why 5 choose 3 has the same value as 5 choose 2. We can imagine that there is a basket containing 5 items A, B, C, D, and E. When we pick 3 items from the basket and does not matter the order of picking them, there are a total of 10 possible ways. It's given by the binomial coefficient 5 choose 3, which is 5 times 4 times 3 over the product of 3 times 2 times 1. It gives 10. For instance, if we picked A, B, C out from the basket, it means that we left behind D and E in the basket. If we picked A, B, D out from the basket, it means we left behind C and E in the basket. Obviously, the number of ways of picking 3 items out from the basket equals to the number of ways of having 2 items remaining in the basket. Therefore, the number of ways of choosing 3 items from 5 items to put outside the basket is the same as the number of ways of choosing 2 items from 5 items to stay in the basket. In general, the number of ways of choosing R items from N items will be equal to the number of ways of choosing N minus R items from N items. Thus, the value of N choose R is equal to the value of N choose N minus R. We can also refer to this simple proof here. Therefore, now, when we need to calculate 20 choose 18, we can use the formula and calculate 20 choose 2 instead, which is much more convenient from the formula. But this formula doesn't give us shortcuts for calculating 10 choose 5 or 22 choose 11, etc., as in both ends, the formula is the same lengthy. Next, we would like to discuss another theorem. Let n and r be integers with n is greater than or equal to 0 and r is greater than or equal to 0 and less than or equal to n. Then the binomial coefficients n plus 1 choose r equals the sum of n choose r and n choose r minus 1. Notice that we have the convention 0 choose 0 is 1 and 0 choose negative 1 is 0. Please refer to the mathematical proof for this theorem. And the example for an illustration for it. We can summarize our findings so far. First, the value of n choose n equals the value of n choose 0, it is equal to 1. Point 2, the value of n choose r equals the value of n choose n minus r. Point 3, the value of n plus 1 choose r equals the sum of n choose r and n choose r minus 1. We observe that these are also the properties with those numbers in the Pascal's triangle. In other words, the numbers obtained by using the definition for binomial coefficients is indeed the coefficient obtained by expanding x plus y to the power n manually. In the following, I wish to give an explanation on why the binomial coefficient obtained when we expand x plus y to the power n is equal to the formula n choose r in the definition. Let us illustrate by using bracket x plus y to the power 3. We first refer to the expansion on the top right-hand corner. When we expand x plus y to the power 3, we can think of having the products of 3 identical brackets of x plus y altogether. To create each term, we pick either x or y from the first bracket, pick either x or y from the second bracket, and pick either x or y from the third bracket. If we focus on y, it means that we decide whether to pick y or not from the first bracket, to decide whether or not to pick y from the second bracket, and decide whether to pick y or not from the third bracket. After we have listed out all possible ways, we combine like terms together. We get 3x squared y because there are 3 ways of getting x squared y. Let us refer to the left part. We still focus on y. How do we get the term x cubed from the expansion? It is obtained by choosing no y from all 3 available brackets. The number of ways is 3 choose 0, which gives 1. Thus, the coefficient of x cubed is 1. How do we get the term x squared y from the expansion? It is obtained by choosing 1 bracket to contribute y, but for the other 2 brackets, we do not choose y, and that means automatically we have chosen x. The number of ways is 3 choose 1, which gives 3. Thus, there are 3 like terms of x squared y, and the coefficient of x squared y is 3. We can get the answer for the other 2 terms similarly. Therefore, the coefficients we obtain by expanding x plus y to the power 3 is the same as the binomial coefficient we obtained from the definition, and it has the meaning of n choose r.